Hello and welcome to part 54. In this video, we will continue our discussion on reflection. In the last video, we have understood the basics of reflection. We have seen how reflection can be used to read the metadata of the assembly. And in the last video, we have learned how we can get details about methods, constructors, properties, class fields that are available in a class. Let's first go to Visual Studio and understand what we mean when we say early binding. I have opened up my Visual Studio and I have created a very simple class with name customer. Customer class is having only one method, that is get full name. Get full name expects two parameters, first name and last name, and it will concatenate those first name and last name and return the full name of the customer. So in a normal scenario, I mean in the 99% of the scenario, what we will do, we will create an customer object like this, right? We have created an instance of customer class and we have used the get full name method and we have passed our parameters. Let's save the result of it in a variable. Let me call it string space result. At the end, let's print the result. And we can see we have printed the full name Peter Parker. So this is what we have been doing in this video series till now. And this is called early binding because at the compile time, we will know where we have the customer class. So when we type customer, this C# compiler will know the customer class is getting referenced from here. If I mistype this name, maybe customer, let's say I mistyped it to customer with double R. Now you will notice we are getting an error here. It will say customer could not be found. Are you missing a using directive or an assembly reference? The compiler now is not able to find our customer class, and that's why we are getting the compilation error. If I try to build this application, you will notice the compilation will fail. You can see the message here, one failed. It means build was not successful. And if you go to the error list, you can see the error message here, customer could not be bound. So it is very important when you are doing early binding, we have to provide the proper syntax. And the benefit of doing it is we can avoid runtime errors. At the compile time itself, we can see what are the errors is there in our program, and this way it will help the developer to reduce the number of bugs. So for now, let's correct this class name, and along with classes, early binding will help in detecting errors when using methods. Let's say if I mistyped my get full name with maybe, let's say if I type get complete name, that time also we will get the error message. It will say customer class does not have definition of get complete name. So these kind of errors can be easily detected using early binding because the compiler will not go ahead and build our program. And if the program is not built, of course, we will not be able to run the application. Along with it, I also want to show you, even if you have the correct method name, compiler will also check the parameters that we are passing. Let's say if I don't pass a string parameter to it and pass some number here, we will again get the error message because compiler is also checking the data types here. Because the first parameter is of string type, that's why we are not allowed to provide some integer value here. Let's go back to slides now. In early binding, we will have compile time resolution. The compiler knows the exact type of the object we are working with at compile time itself. This means we can easily verify our methods properties that are available for the object. Early binding will provide you fast performance because everything is checked at the compile time. Early binding generally leads to faster execution. Better error detection. As we have seen, in early binding, compile time checks will help us to catch errors early on. This way we can prevent runtime exceptions. Okay, now that we have understood the early binding, let's move on and understand what is late binding. Reflection uses late binding to provide us the information about metadata of an assembly. Let's understand how. When we are doing the late binding, it doesn't matter if we have the customer class with us or not. Let's say I have type t equal to type dot get type. And within this get type method, I can provide my customer class namespace or the customer class fully qualified name like this. So even if I comment out here and if I try to build the application will build successfully. And even if I misspelled the customer class, let's say customer like this, and try to build the application, that time also the build will succeed. And now we are not able to detect the errors because this is late binding. At the compile time, we will not check for errors. At the runtime only, when the code will actually run, we will go ahead and try to get this type. If I put a breakpoint here and run the program, you will notice type will be null because we are not able to find this customer class, right? So in case of late binding, the types will be resolved at runtime, right? The specific type of object is determined at runtime. This can be useful when working with unknown objects or implementing features like plugins. Usually, when we use late binding, the performance will be slower. Late binding involves additional checks at runtime. So instead of checking the errors at compile time, we will be doing it at the runtime. This will make our program slow. Potential runtime errors. Since type verifications happen at runtime, there is a chance of errors like calling a non-existent method. So let's go back to Visual Studio and understand more about late binding. Here again, I have my class customer and I have created a type T. Let me again make it customer. Now, if I want to create an object of customer class, what I can do, I can use activator class and I can invoke create instance method, and within it I can pass the T. T is nothing but the type of which we want to create the object. And let's store the object instance that is created by activator in an object type variable. Okay, this is fine. But let's say I mistype my customer class now. I will say demo.customer2. And now if I try to create the instance of customer2 class, let's see what will happen. If I run the program, you will notice we are getting the argument null exception because at line number 12, when we try to execute get type method and pass down demo.customer2, the .NET framework will not be able to find this particular class and T will be null here. And we cannot call create instance method with a null type. That's why we are receiving this runtime exception, argument null exception, value cannot be null. So guys, it is very important to make sure you are providing the names correctly, else we will receive the runtime errors. So now I have the proper spelling of my customer class and the object will be created using activator dot create instance method. Once we have the object, what is the second step? Second step is to find out the get full name method. To find this method in reflection, we have the method that is known as get method. So on this t type, I can invoke get method, right? And within this, I need to pass the method name. And the name of the method is get full name, right? And the return type of this method is method info. So let's create an object of method info type. Let's call it method equal to whatever the method is returned from this statement, right? Once we have done this, now we have our object, we have our method. What is the third step? Third step, we have to arrange our parameters that we have to pass to our method. because we have two parameters here. So let's create an string array. Let's call it parameters or params equal to new string array, and let's pass the first parameter as hello and second parameter as world. Okay, so now we have our object here, we have our method here, and we have the parameters here. Let's change the name of it because params is a keyword. So now we have the object, method, and parameter. Now we need to do the final step, that is actually go ahead and invoke this method. For that, we can call method dot invoke. And invoke will take two parameters. One is the object. So we have the object obj, and second one is the parameter that we have to pass to our method, like this. And if you check the return type of it, it is an object, right? But we know our get full name will return a string data type. So let's create a string variable, string result equal to. If you notice, we are getting an error here because we cannot convert object to string directly. For that, we have to do the typecasting. So let's provide the string here to do the typecasting. So once the typecasting is done, we can go ahead and print the result which we have received using console.writeLine. Right? And let's run the program now. You can see our program is running and we have printed hello world message here. So we have successfully executed a method using reflection. But point to notice here is it is very important to provide the correct names when using the reflection. If I mistype this get full name here, and if I run the program now, you will notice we will receive the exception at runtime. We are receiving null reference exception. Object reference not set to an instance of an object. Because at line number 16, when we try to get this method get full name 33, it will return the null here because we don't have any method with this name. So we have to be very careful when using reflection and when we are doing the late binding. That's it for this video, guys. In the next video, we will learn about generics.